Okay, so we got as far as showing how Newton used his guesses and his hypothesis to demonstrate Kepler's law of periods. So let's take a step further and see if we can validate Newton's law, his universal law of gravitation. And let's consider the moon. We know quite a lot about the moon. He would have known quite a lot about the moon. So let's assume that the moon is performing a circular orbit, as Newton said that they were, or it is. Then we have a circular motion, centripetal force, mr omega squared, and of course omega is 2 pi over t, and we know the period of the moon's orbit, so that's good. So we can get that in there. We can say mr 2 pi over t, square that gives us mr 4 pi squared over t squared. Now, Newton said that this force was some constant times the mass over the square of the radius. So let's equate those. We'll cancel the masses and we'll get the r's together. So we've got 4 pi squared r cubed gives us kt squared. Let's call that equation 1. So let's now consider the moon on the surface of the Earth. And that way we can get rid of k. So, if the radius of the Earth is r, then this moon is performing circular motion, F equal to km over r squared, right? And of course that will equal mg. That is the gravitational force of attraction of the Earth for the moon, right? So we can then get an expression for k, which equals r squared g. Now, we have an expression for k, r squared g, which we can put in here. So let's do that. So we now have 4 pi squared r cubed equals r squared g times t squared. So if we use this to get a value for g, if we rearrange this to get a value for g, we'd have 4 pi squared r cubed over big R squared t squared. Now, we know this, and we know this, and we know this, and these are things which we can then use to check the value of g based on Newton's ideas. So we have, let me just get rid of that equals, we have the radius of the orbit of the moon, 3.8 times 10 to the 8 meters, quarter of a million miles. We have the radius of the Earth, 6.4 times 10 to the 6 meters. We have the period of orbit of the moon, 27.3 days. So that, of course, is 27.3 times 24 times 60 times 60 seconds. And if we substitute all those numbers in, we get g to be 9.51 meters per second squared. So there we have a figure which is tolerably close to our accepted value of 9.81. So it's looking pretty good for Newton's universal law of gravitation.